Okay, so this is the first of the R videos. And basically all I'm going to be doing is I'm going to be going through the SPSS stuff, but in R. So we have a file, it's BQA9333Week2. Important that you store it in the same directory that you store your actual data file in. And today we're going to be using exactly the same data set that we utilized in class. And we're even going to include the SPSS. We're actually going to have it in SPSS format, but we're actually going to convert it. So let's just kind of start off with the first command. And just as an aside, before you follow these videos, you really want to have maybe done the intro to R and intermediate R in the data camp. Okay, so we're going to set WD. And all that does is it sets the working directory to the PhD class. Now, what you can actually do is you can do this manually. So I'm going to do session, set working directory, choose directory. And we've got R. And you see, this is my PC. I've got my documents folder. I have a lot of junk on my PC. We have R. And then we have PhD class. And click open. And then we have, you see, this is actually the same code, but this little squiggle here is basically shorthand for the documents directory. Okay, so we're in the right directory. Now, R has what we call packages, and they enable to us have additional functionality relative to the base R. And what I always do, you don't have to do it exactly like this, but this bit of code basically says, if we don't already have foreign installed, this is what require checks, then we install it. And then library actually loads it into memory. So if it's not already there, we install it and then we put it into memory. Now, all foreign does is it allows us to utilize formats that R would not usually use. And read SPSS is one of those. SPSS is one of those formats. Now in R, we can do a little question mark, which is like a help, question mark read SPSS, and that will actually give us the information about what read.spss does. And it tells us, okay, we need a file, and then these are some of the potential parameters that we can add. We're just going to use one of these, and we're going to do all the defaults, but we're actually going to convert to a data frame. Okay, so we now have IHNO in memory, and let's just have a look at our environment, which has lots and lots of files in at the moment because my environment's a little bit messy. But we should see IHNO, which has 100 observations of 20 variables. Actually, I can show you something else while I'm here, which is RM list equals ls. That basically removes everything from your environment, and then we'll just kind of repeat that code. Note that in R, when we're assigning, we can use the equals, or we can use this little notation here. This does exactly the same thing. Okay, so a few other commands. str. This just shows us what it's a little bit like, you know, the view that we had in SPSS, where you could see the actual variable view. And this just tells us all the variables and what they are. So we can see, for example, that gender is a factor, major is a factor. So let's just have a look at major. And we can see this is the major of all the students, and it tells us that this is a factor variable. It tells us the different levels of the factor variable here. Now, view just gives us almost like an Excel or an SPSS worksheet. So this allows us to see, you know, the data almost in worksheet format. So you can see here the first person is a female, psychology, advisor recommendation, easy exam, etc. Okay, so we're going to do what we did with SPSS, and we're going to define Math Quiz 100. Now, this is one thing that's probably easier than R than SPSS. We just do a simple arithmetic. And we also, let's just do a little bit more arithmetic. We want to see how the heart rate changes between before and after the exam. So we have heart rate pre to post. We also we're doing work with Math Quiz 100, but if we look at Math Quiz 100, let's just do that. You'll see that we have lots of NAs. NA is our way of saying that this is missing information. And there's actually a function called is.na. So we can see all the items that are actually missing, not there. And then we can actually do is.not.a. Not is.na. Oops, and I forgot the bracket. And you can say that these are the ones that are not, NA. So what we're going to actually do is we want to plot the Math Quiz 100s, but first we can't really plot any of the NAs. So we're just going to define plot val, and all that is basically saying is these are all the values. And then plot major, we're just basically getting the major for everything that's not NA. And then we can actually do a histogram. The histogram function is really, really simple. So hist plot val. Oh, and crap, that probably means I've not made this big enough. There we go. What on earth happened there? Let's do the histogram. That's better. Now, what I did with dev.off off, that just basically resets the plotting environment. I think the plotting environment got it a little bit messed up. So let's just actually write this in the code. Let's just put reset plotting environment. Before starting plotting. So it just makes our code a little bit more secure. Now we can change histogram. So let's just have a look at help for histogram. And histogram, again, it has lots of parameters. We can set like the main heading. We can set the X limits, the X range. We can set labels. We can set axes. But what we're going to do is here we're going to set the main title is histogram of Math Quiz 100. We're going to label the x-axis as Math Quiz 100. We're going to set the border color as black for the bars. We're going to set the color as dark blue. And then we're going to do breaks equals 10. And basically probability equals false is we're just doing a count for our histogram. We're not doing a proportion. So this is what I'm going to call the fancy histogram. And here we go. We've got a nice blue histogram. We see our axis is labeled. We have a title. And we can do exactly the same as before, but this time we're going to do probability is true. And you see here now we have a probability, we basically have the proportion probability density rather than the actual probability. Okay, so now we're going to do something else. We've got the plot values. We're going to use the mean function to get us the mean value of the plot files. And then we're going to define the standard deviation as the square root of the variance. Why did I do that? We also have a function called std as well. Whoops. Okay, so we could have actually done. Oh. Yeah, SD. So we could have also done the standard deviation. So I'll put as a little bracket, could also do SD plot val. Obviously I was just messing around there. I don't know what I was doing, but this is actually perfectly correct code, but this is just a little bit more efficient. Okay, so next thing we're doing is going to plot a normal curve. What the denorm function does is this basically, given a value, it will give the probability density in the normal distribution defined by a certain mean and standard deviation. Again, we haven't really covered this in class yet, but just like it will draw a normal curve over the top. And we're going to make this curve red. That's just kind of how, wide the line is. And we're not going to draw a new graph. We're going to add it to an existing graph, and we're not going to mess around with the y-axis. So we're now going to draw a curve, and you can see a normal curve on top. So you can see how close our distribution is to the normal distribution. Okay, so let's just do a different type of chart. So let's just have a look at plot major. This is people's majors. Now we can actually get, we can actually extract, if we have a factor variable, we can look at the levels of this. So we can see these are the different levels these are the different potential majors who are taking this stats class. Now, ggplot2, this is part of something called the tidyverse, which is a set of routines designed to make things, to give you more sophisticated features than the base are. It's mostly data manipulation and visualization. There's a class, if you go to my data camp, the second class I assign in that data camp, mainly for the undergrad students, is Introduction to the Tidyverse. Okay, so what we're going to do is we're going to do ggplot. ggplot, it always takes in the data file. It takes in the AES. AES basically tells us what information, what data are we going to use from that data file. So on the x-axis, we're going to have the math quiz, and we're going to fill by major. And then we're going to do a histogram. And then we set, it's very similar to SPSS. You can set the number of breaks. You can set the bin width. Here we're setting the bin width. So this is a ggplot. We're filling by major. As I said, this is similar to the ones we did. I'm not a big fan of these type of graphs. They just look a little bit like a dog's breakfast to me. But we can try a couple of variants. That's like a fill chart. We've got the position equals fill. I don't know if that's any better. I don't know if we like that. Or we could do the one we did in class. There we go. And we can see the distribution by gender. So all I'm doing is I'm kind of trying to recreate what I'm doing in class. Now, you can actually, with the histogram, you can actually set your own color scheme. And you can use a function called scale fill brewer. And we're using a certain palette we call spectral. So just let's have a look at the help for scale fill brewer. And this just tells us, a little bit about the function, and you can pass it a palette. And the most importantly is it actually gives you a list of potential palettes. So let's just do, let's just try this, and then let's just do dark too. So here we go. This isn't a particularly nice one. Let's just do dark too. And click enter. And there we go. We get the same thing with a different palette. So there's a degree of flexibility you don't have SPSS. Okay, so this is the population pyramid. This is there might be a better way of doing it now, but let's just go with this. So we're setting the breaks in our chart. And so these are the breaks going to be in the exam results. And all it's just saying is we're going to split the exam grades up in between these kind of, into bins in between these values. And now we're going to use the cut function, which is actually going to do that. It's going to take these breaks and it's going to assign variables to those breaks. So every variable now, it's no longer a continuous variable. It's telling us which of these different bins it's going to be in. And it has 20 levels for each of the, each of the 0 to 5, 5 to 10 bins, etc. We're now going to have, so let me just make sure I assign all those variables. We're now going to put these values into a table. So it's just basically saying how many we have of each. So you can see we're getting closer to a frequency graph. Basically, we're going to do define all the midpoints of these breaks. And all this is saying is breaks -1. It's just kind of taking the, it's taking something from the one before, and then it's finding the middle. So this is the midpoints for all of these different breaks. You can play around with that if you want. Okay, so let's do the plot. So you see on the X, we have the center points. This is the frequency polygon we did in SPSS. Then we have, the frequencies are a little bit weird. Let's just see what we're plotting on the Y-axis. Oh, I guess it's because it's named. So let's just change that. We can remove the kind of the headings for the frequencies just by as.numeric. It's plotting the wrong thing. And then perfect, we have the actual frequencies. So the plot, this is just the generic R plotting function. We plot X, we plot Y. PCH is like the shape. We're just using a dot. So if we did like question mark PCH, you can see these are all the different shapes you could have. CEX is like the size of the shape. We have the frequency, the title, the X label, and the Y label. And then we add the lines extra afterwards to the actual plot. Okay, so that was the plot for the histogram. And now we're basically going to do cumulative frequencies, so it's going to be the same. Let's just get back to the plot. So we're going to take the plot.frequencies and we're going to do what we call a cumulative sum. And let's just see what that gives us. And basically, it's just adding up all the frequencies to give you cumulative frequencies. So we had a 1 and a 4 before. Now we have a 1 and a 5. 1, 4, 3 is 1, 5, and 8. And we added like an additional 0 at the beginning to give a baseline. So now we're going to do the plot. Oh, I have to define cumulative frequency. And you can see this is the kind of the cumulative frequency plot. Okay, now this is the population pyramid. So this is actually, I'll just go through this quickly. So this is a little bit complicated. We're going to define the breaks as before. Then we're basically, this is just telling us everything that's male, where the gender's male and the math quiz is not missing. This gives us our male points. And then we do exactly what we did before, in that we actually, we utilize our breaks to create the cut points. So nothing different now. And then we do a little frequency table. But note, you'll work this, we'll kind of be enlightened a little bit in a minute, but you see we've made all the frequencies negative. This is because we're going to put the males on one side of the graph and we're going to make the frequencies positive for the females. So we do exactly the same for the females, but we don't multiply by -1. So here we go, gender, female frequency. And you see we have the frequencies for gender. So we're now going to combine in a data frame. Again, I can't go through data frames from scratch here. This is you're probably going to have to do in the intro to our course. But we've just combined, we've got a gender male frequency and a gender female frequency. But if we didn't do select columns, we would have like the actual frequency bins twice, one for males and one for females. So we actually remove column 3. So you can see the cut points, we don't want it twice, so we just remove that for the male. We turn our cut points into text. That's just as character. And then we actually give some names. And this is our kind of now source data. So we have our bins, we have our male counts, which are negative, and our female counts. Now for ggplot, this is the wrong format. This is basically, we have males and females and we want to plot both, we want these kind of as a factor variable. This is what's called kind of wide format, and we want long format. So we use the melt function from reshape. And again, I'll let you just kind of look over what reshape does. But it's just basically for changing the wide format to the long format. So we use the melt function, and we're going to have the ID as the bin. And I'll just show you how that works in a minute. And we're going to do the names. And look, you can see what it's done is basically we've kept the bins, but which is our ID, but we now have the male frequency, the female frequencies, and going from wide to long, we've basically just appended the females to the bottom. And here's our final plot. So we have the X in the bin as the bins, the Y's as the frequencies. We're going to fill by gender, and we're going to kind of do two different bar charts. One for the females, one for the males. We're going to use a function called subset for that. And doing G on bar with stat identity just as a standard histogram. We're going to define the scale, going from -14 to 10, because we need the males as well who are negative. Coordinate flip, we're going to go from the x-axis, we're going to just swap the axes around. We're going to set our palette. We're going to give it a title, and theme BW basically means we're going to have a white background. So there we go. This is you can see that what will happen with coordinate flip, we basically have two bar charts that are now kind of horizontal rather than vertical. So this was definitely not easier than SPSS, but it's a good example of how you can build graphics up over time. Okay, so we've still got box plots and scatter plots. We can use the standard box plot function. This little squiggle here, in this case, it means we have Y squiggle X. So we're plotting Math Quiz 100 by reason. We're going to give it the data. We're going to give it the column name. We're going to give it an X label and Y label, and we're going to color it in blue. And there we have what happened to our remaining reason. Here we go. I was a bit worried there. So we have program requirement, personal interest, advisor recommendation, exactly the same graph that we got in class. Now, the more complicated box plot, we're going to have to use ggplot. So here we have the reason. We have Y is the X is 100. We're going to fill by gender. And we're going to use geonblocks plot with ggplot. Again, ggplot's the function. You pass it the X and Y, and then you give the separate function that determines the type of plot. We use scale fill brewer before. We're going to use scale fuel manual, and it's just basically saying we've got two values for each gender. We've got blue and red, and we're going to give it a title using GG title. Again, I like white backgrounds. I'll show you what happens if I didn't do theme BW. We get this horrible gray background, which I don't like. So that just makes the background white. And then again, we go exactly the same with SPSS, though note that R seems to calculate the outliers a little bit more differently. So we have an outlier here for program requirements and an outlier for personal interest. As I said, generally an outlier is anything from the bottom of the top of the box more than 1.5 times the interquartile range. Okay, so the last thing is a simple scatter plot. So we're going to plot the heart rate pre and the heart rate post. We're going to give it a title main. We're going to give it an X label and a Y label, so really simple. And there we have the scatter plot. Now we can mess around with this a little bit. You know, with the previous plot, we set the value of PCH. Let me just get back up to this giant plot. Okay, so let's just do question mark PCH. And what do we want? Let's just say we want a dot. So let's just do PCH equals 16. And now we got it plotted in dots. And we might, then we can set the size, CEX. There's lots of things we can do with that. Now, the last thing we're going to do is we're going to use the pairs function. And the pairs function is part of psych. And let's just have a look at pairs. In fact, the basic pair function is just part of the basic graphics routine. So we're just going to run the pairs function. And this gives us the scatter plot matrix that we had in class. You can see, for example, heart rate pre and heart rate base. There's correlations. There's correlations between the two lots of anxieties. But say between anxiety and heart rate, we just get a big blob. There's no real correlation there.